Hello, everyone. Of course, Scott already gave my name. And we are a local company, and we are primarily focused on blockchain space. And what I want to do, or I want you guys to participate as possible in between. You can ask questions. Probably I may be talking so many things. You may find you may have questions, so don't wait for the last moment. And I would definitely engage audiences definitely better than my monologue, which definitely I don't enjoy. So to start with, if we look at the blockchain, I think what we realize is blockchain is going to change the way we do some of the things in our daily lives. I think that's what our thinking is, and that's the reason we are focusing on blockchain. So before we start talking about the other part of the risk and securities, and definitely blockchain, Adam and Akshay, they have already covered really well the basic about the blockchain. So probably some of the slides may be redundant now, but I will try to give you a close assessment the way we are looking at the risk and the security, how we are trying to create our blockchain. I shouldn't say better, but of course it's better, right? I mean, that's what I'm supposed to say. So now let's move on to the next slide. So do you see what's the problem with this slide is? I mean, one other thing you realize, and I think that's what we have been telling, or at least in print or media, you hear that blockchain is a trustless system. Now, looking at this slide, the first thing comes to my mind is, if it's a trustless system, how can I trust these people, right? I mean, you shouldn't be trusting whoever is involved. Of course, I pixelated the company name, but I'm sure you can figure it out with doing a simple search. So the biggest problem with this whole ecosystem is a problem with the ecosystem, not necessarily a blockchain as a technology, right? Blockchain is one part of the whole ecosystem what we are talking about. In this case, there were a bunch of factors involved, and some of them, they did not have enough risk assessments, or they didn't implement proper securities around it, so they have to deal with these kind of problems. And of course, if you hear these things, then everybody thinks that blockchain has a big problem, and the people start talking about the risks, people are talking about securities and whatnot. So one of the problem with this one, and I'm going to cover more in my next slide, which is about the risk. Let me move on to the next slide. And let me step back. So I think what and why, I think Adam and Akshay already covered, immutable distributed ledger, and you can read through these things. And I think I'm going to answer one of the questions, is the why we need decentralization, right? So if you look at this one, public blockchain help parties to come together and exchange value in a trustless system. So I think that's what we need blockchains. And let me move to the risk slide. So I think some of the people, they have already covered the risk. From a business side, I'm sure most of the companies, they are involved, or they are doing some of the projects on blockchain. Is anybody who's not involved with the blockchain, or their companies not doing any project on the blockchain? Anybody? I think most of the companies, so there are exceptions, definitely. So most of the companies we talk to, they are definitely looking into the blockchain as how they can use their business processes primarily to improve their efficiencies and whatnot. I think if you look at it, the way the technology trend is, mostly we do things to improve efficiency around us. It doesn't matter what kind of business process it is. We want to slice it, we want to take apart and make a more efficient process. I think along the process, blockchain is the kind of technology which is going to do that. And one of the things Adam, I think, talked about the intermediaries, and that's the key for blockchain, that taking out the middleman out of the equation. And that's where most of the use case we have been looking into, where we can bring more efficiencies, take out the middleman out of it. So from a risk point of view, I want to talk about some of the risk. I think one of the is the uncertainty around the regulations. I think this is one of the biggest risks, and Akshay covered them really well, and he categorized them in a different category in terms of how they fit with red, green, and white. And the way we look at it, these risk primarily from regulations. To give you an example, from a security side or from a financial side, there are 5 or 6 federal agencies involved. And primarily you hear about CFTC, which is Consumer Finance, and SEC. So regulation is a big problem in terms of how you deal with that. And we, couple of weeks back or few months back, we did our own private sale. And one of the things we were advised how we project or how we say that we are doing our private sale. We can't say securities. It was a complete privately managed token sale primarily. And if you consider these kind of factors, so that's kind of bump in the road, right? We can't do some things. And I think Adam already covered one of the companies now, they are under investigation for securities law. And another thing is within the US, the biggest problem from a regulation side is different state, especially New York has a different regulations. You have to file Reg D and different kind of forms there to get, if you want to do anything with your token sale or you want to do any, or with cryptocurrencies. So one thing you have to see from a risk side is how much is the reality and how much is the hype around it. You know, as you have seen in the past with every technology, we have seen a hype, certain cycle. If you go 15 years, I'm not sure everybody follow technology or not, but if you look at since late 90s and early 2000s, there were definitely different technology cycles came. You know, some people were talking big data. Of course, people still talk about big data. Then there was a social in the past, and now people are talking about AI and machine learning. And in the same trend, if you look at the software-wise, blockchain definitely is a software, and people are talking about the software now, blockchain now. So how long it's gonna last? It's a question. But the utility-wise, the way we see, definitely blockchain has a big potential in terms of how you govern things around you, from a society point of view. And so that's where the regulation part comes into picture, right? And then another thing, Adam also already covered with the privacy and the correlation of the transactions. So people have a notion that every transaction can be traced back. That's true, but there are now technologies possible where you can hide those things. I think he already mentioned about the zero knowledge proofs and whatnot. And so the way we are looking at it from the risk point of view, probably we're going to provide a portion of a feature set in a way that from a enterprise setting, you can have a portion of your transactions made public for auditing purpose, and some of the transactions you can keep private. So from a transaction point of view, a lot of people are talking about the different type of blockchain. I want to cover or touch upon a little bit about the public versus permission versus private, and then sometimes people talk about the side chains also. If you are familiar with them, the public blockchain is anybody can participate. Permission is only few people are allowed, and private is you create your own group and do the transactions around it. So there are different mechanisms how you deal with the transactions. And similarly, there's a 1/4 item. People lots of time they talk about the side chains. People do their transactions on their own, and then they merge into the public ledger. So from a privacy and transaction risk point of view, right, you can eliminate these kind of things, or how you deal with them. I think it's up to you guys what kind of blockchain you wanna manage through. And I think I didn't cover about from the privacy point of view how or how the blockchain is being used now. in the settings, right? So probably I will cover more the risks about the business risks when you are talking about the using a particular blockchain in certain settings. I think that I will cover in later slides. And if you look at the risk, I have categorized in different buckets. So, the top 4 are primarily focused on business risk, what we call, and then the middle 3, what we describe as a technology risk. And second, or the last 2, primarily they are much more focused on the investor side or investment kind of risk. So most of the cryptocurrencies are very speculative, and I'm sure why they are speculative. I think you'll find different people answer differently. And at the same time, when they are speculative, they are definitely complex in terms of how you understand them, right? The technology behind it, only few people understand. And the way we are doing things with blockchain, we haven't made them very easy for people to understand or use them. I think that's one of the barrier or the risk getting into blockchain spaces. So next slide, I'm going to cover a little bit about the securities. Security is essentially a subset of the risk, what you have already seen, but here we are much more focusing on the technology side primarily. So I think one of the security risks is the mining centralization, which Adam already covered about the 51% attack, and where he talked about the, if you have a peta hashing power, you can overtake any public blockchain or any other chain. And then privacy around transactions we already covered with the zero knowledge proof and G-snarks. Another is the security, securing your private keys. I think this is one of the biggest problem, and Akshay already covered about it, throwing his hard drive. So this is one of the biggest problem, how you manage with your phone. If you lose your phone, how you're going to recover it. And if you're writing your private keys in some piece of paper, of course, you have a problem with the securing them, right? And then one of the notions you will hear in blockchain space that, you are your own bank, right? If you're your own bank, nobody has the responsibility, you are responsible. And most of the people, they don't want to take the responsibility of, some things, manage these things. So one of the biggest problem is how to take the backup of your private keys, right? I mean, you have to be pretty cautious about it to take the backup. Make sure the technology-wise how you can take the backup and restore and that sort of things. And most of the people, I think they don't want to deal with the technology most of the time, right? So there are some tech-savvy people, definitely they want to deal with these kind of things, but most of the people, they want to avoid dealing with the technology on daily lives. So one thing we need to also realize that, I think I have mentioned somewhere, being a software in any blockchain, there are going to be bugs in it. And I think having bugs is the biggest problem, right? How to identify, even no matter how good you are architect or developer, there will be unintended features that will definitely come into your software development cycles. And I think that's where Deja Vu team can get involved, can help you to help sort throughout, with this process where if you have these kind of bugs, which can put you in a situation where it can undermine your whole business processes or your business model around it. So from security side, another thing we need to consider is the application security and user level security and the platform definitely. So if you recall the first slide I showed you, that's where all 3 things comes into picture, right? So end user, as an end user in the blockchain space, you have to do your own due diligence to make sure the application you are using is coming from a reliable or authenticated source, or these people you can trust. So now this question comes back, in a trustless system, you are trusting some person who's giving you an application, right? That's one of the biggest problem. I'm not sure if we can solve this problem pretty quickly, but that's where you look at the credential. And if you're talking about the credential, in my business slice, I will talk about the identities. I think this is one of the business case we want to solve with the blockchain, which can eliminate these kind of problems, right? How to trust certain application. So for example, if you go to App Store in either Android or Apple, you know that Apple has or Google has done their due diligence around those apps. Still, you can see there are apps they are taking your, reading your data and uploading to somewhere. So we have ways we can mitigate these kind of security risks, but still you have to be very cautious about what kind of application or what kind of platform you are using. So talking about the platform, one of the security risks we say is the hosted wallet system can be gamed. So a lot of people in blockchain space, what they are doing nowadays, they have hosted wallets, right? So if you look at the the third one, you own the private keys. And I don't think any speaker so far covered what are the private keys. Let me step back and explain you what are the private keys, what we are talking about. First of all, when you are interacting a blockchain, you need a piece of software. That's what we call wallet. There are different type of blockchain and different type of wallets, but from essentially a wallet is a combination of public keys and private keys in a simple form. In one case, securing private keys mean you are responsible for your own keys. That's where phrase comes, you are your own bank. And then second is the hosted wallet system. It's like using your email account, right? So you know the email account, you enter a password, all emails come. So this is kind of setting I'm talking about. And the first setting is primarily you own the hosting email also, you are getting all in your server. So the way system is designed, in this case, the transparency is not there. So you never know in blockchain space how people are going to, or how they are managing their own private key. My personal experience interacting with some of the hosting systems, they do not have real good security. You from outside, you don't see really well, and then there's a testament for Yahoo hack and everybody get hacked. So there are only few companies in the world, you don't hear about them, but most of the companies, and those things happens because there is a lab security behind their, what you see on the wall, on the website, right? So this is pretty common. And one of the security problem is the programmable code deployment, right? That's a biggest problem. And why it's a problem? So if I'm writing a smart contract, I will come back what a smart contract is. Anyway, Adam already covered it. The programmable code in Ethereum world is called, or any blockchain world is called smart contract in pretty high level. I'm just giving you 100,000 foot kind of rundown on that one. So when you have these codes, when you are deploying on a blockchain or any machine, you have to trust those things. And that's where the biggest problem comes, right? So then depends upon the developer's skill set, how efficient or how good they are writing their smart contracts on these programmable code blocks. If they haven't written if they are not good at it, definitely there'll be a problem. And I don't want to point some of the older problems with that. The developers were pretty good, but still they were slip-ins, right? DAO bug is a pretty prime example, and I think one of the slides Akshay covered it, or I think Adam, one of them covered it, where they were talking about $55 million. And to eliminate that problem, they had to do a hard fork, and that's another problem we have. And I think Akshay covered in one of the things he mentioned, I found pretty interesting in one of the last slides, that what he sees in future is the hard forking. And I will talk about hard forking when I talk about our platform, why hard forking may not be the best for blockchain ecosystem in general. Basically what happens is fragments the market, and so fragmentation is definitely not good in terms of the adoption. Then people have too many choices, and of course it says the freedom, but at the same time it's a problem also. Then people have hard time to decide which system to adopt or which systems to good for them. So another security problem in terms of the I think social trust, the second last bullet point I'm talking about, I think it's correlated with the wallet system, which is primarily on the number 4 bullet point here. And in blockchain space, so blockchain under technology is definitely decentralized, but the application built on the top of it are definitely centralized, right? I mean, if you look at the most of the applications, I'll give an example of it's like games. Unicorn guys, Summit talked about it, but as a service, they are providing as a centralized service, but the underlying technology part of it they are using as a decentralized aspect only for the token. From security, the next item is the future of computing. So one of blockchain relies, I think, I don't know if Adam covered it or not, but one of the things is primary is the cryptography, right? So you may hear the ciphers, you may hear the hash rate and whatnot. So those are the things at this moment with the current computing, the way we are using, I think it's good enough, but down the road we may have really, really good computers, and that's where peta hash comes into a picture. If they are pretty good computers, they can crack those kind of cryptography pretty quickly. And so with the blockchains, another problem is the block, the way they created, right? So let me touch upon the security. I think let me give you one fundamental why blockchain called block. So the reason they call blockchain block, they are transactions. So transactions simply, I'm sending you some amount, and in this case happens to be a cryptocurrency. To make it or to put into a ledger, public ledger, what they do, the blockchain software creates a blocks nothing but number of transactions in one block, and then they keep putting up into blocks, and these blocks are related to the prior blocks. I mean, it's a pretty rudimentary, I guess, explanation for the blocks. So if you have a really good computing, you can go back to the beginning of that blockchain and create the whole blockchain, and you can make this, already the blocks redundant, but you need a really good computers, and then you need time, and then they can create the whole blockchain from scratch. So I think one of the hacks, these guys are already, the prior speakers, they already talked about those hacks. I think I have covered most of the things on this one. And so speaking of risk and securities, the primarily why I'm here to explain you a little bit more about the blockchain or the project we are working on and why we are different than the other rest of the blockchains. So primarily what we call our blockchain is a next generation blockchain. And if you want to hear in versioning, it's if you want to call Bitcoin 1.0, Ethereum 2.0, we are calling ourselves as a 3.0, a little more advanced version, which had some of the good features which are missing from earlier versions. And one thing I want to say, the design of Bitcoin, this is one of the best thing came out of Bitcoin blockchains, the design. I think design will remain same, and that's what the future blockchain are going to definitely use the same design pattern. But the way they implement it and how they want to use it may change, and I think that's where we come into picture. So one of the things we talked about is the transactions rate. I think in one of the slides you saw that they have 3 or 4 or 5 transactions in one blockchain. Another blockchain they do 7.5 to 20, average 13, 14 transactions per second. If you want to make these blockchains useful for I shouldn't say mission critical, that one part of the game, but if you want to make it useful for the normal users, I think this transaction rate has to go really, really, really high. If you look at the Visa, the kind of transactions they do per second is pretty thousands in thousands, right? If you look at when there's a holiday season, that goes to 4,000 or 5,000 per second, which is kind of peak. But even if you look at the average, which is 1,500 transactions per second, I think it's a pretty staggering big number. And I think that's where we want to go. That's where most of the blockchain or the improvement people are working on. That's what they are working on. So scalability, when people talk about, there are a bunch of things associated with that, right? It's a one word which defines some underlying technology changes what we need, and that's a problem we are talking about. So why we are different from other blockchains? So the model we are using or the way we are creating, some of the things I have written up here. If you look at the first column, concurrent process model and namespace, and then definitely there are 2 more, Rolang and RoVM, I'll cover them. I think to start with, our mathematical model starts with the pi calculus. So one of our co-founder, he's a mathematician, and the idea when we thought we are going to create a new blockchain came up. Then the model what we are looking at is the concurrency model. What concurrency mean? There are multiple processes running together to achieve certain tasks, right? So if you look at the current blockchains, the way they create those blocks I was talking earlier, it's kind of sequential. So looking at that sequence takes, so what happens then you can't pack too many transactions, right? Then you can't achieve that kind of transactions rate what we are, if you want to make your application meaningful. So what we have done with this concurrency model, we have improved upon the pi calculus, which is concurrent model of processes, and we call row calculus. Row is our HO is for reflecting higher order. And so to make it happen, we created a language called RowLang. So our co-founder and we realized that we need definitely new language to make it happen and to achieve, if you want to achieve these kind of transactions. So what we call RowLang is a process concurrent language, and we write our smart contracts using RowLang, and then that smart contract runs within the RChain platform, what we call RowVM. It's similar to EVM, which is Ethereum virtual machine, and in our case we call RowVM. So I think from a time point, let me do a time check. So let me run through it a little quickly. So one of the things, in other blockchain space, people talk about the space, right? How to achieve even more transactions using one term they usually use, or you may hear, called sharding, basically slicing the way they do transactions. For example, a transaction in China is, if it's not related with Seattle, they don't have to be put together, and that's what the blockchain slows down. And this slows down, or the sequencing of the transactions in a blockchain definitely is a security measure also. So what we need to do to overcome with the transactions, we have to do two things. Number one, somehow we have to make our system so secure, and second, somehow we have to increase the transactions rate in terms of how we can pack them in a block, right? So how we achieve that? So to achieve this parallelism, we use a mechanism called namespacing. So let me give you a little bit definition on namespacing. I'm going to read out from here. And so namespace is nothing but the way you, how you treat your components inside your blockchain, right? I don't want to get into much more object detail, but if you're familiar, then basically we are creating a namespace. Everything is named as an object, and then they have a certain way we call them, which is equivalent to your URL. If you look at the URL def, if you go to facebook.com, they may have one domain up, which may be photos.facebook.com or messenger.facebook.com. Same kind of notions we have taken, which we call URL, and that we split into namespaces. And one of the things blockchain, pretty important portion, I think we haven't talked about within the blockchain, how they distribute the data size, right? So far the blockchain, in most of the blockchain, they have pretty small data size, or the transactions are pretty small in size. What we plan with our model, with concurrency model and pi calculus and row calculus, we plan to add distributed content delivery along with our blockchain. It's a pretty, the target or the goal, it's so what I want to say that achieving these things together, it's pretty hard, right? I mean, when you have a blockchain, you are trying to create a scalable blockchain, and on the top of that, you are adding distributed content. In Ethereum world, there is a product called IPFS similar to that, but we think that with our mathematical model, we can create those things together, whether you want to do transactions or you want to do content at the same time. And why we think we can achieve these things? So the way we are doing is what we call correct by construction engineering, and of course using mathematical model, and we think we can achieve that kind of transactions or that kind of scalability. And so if you look at on the right-hand side, so this portion up to on the left-hand side, I'm primarily focused on the platform which provides you the technology for the transactions and then content delivery. And on the right side, that's where we much more focus, or my role within RChain is focus on the these application side, which is sit on the top of the blockchain. And I should have to go. So there's a simple comparison. I think you have already seen the first two. We don't have to go there. And in RChain, what we are describing is we want to achieve scalability thousands, and of course the consensus how you pack those transactions into a block, into blockchain. That's called consensus mechanism. We are using a different proof of stake, which I think Adam already covered it, concurrency, and you can see some of the differences. And so in this, the last line is the token, right? People talk about blockchain. They always talk about the technology. One of the key portions of the blockchain is the staking token. I think you may not hear much about the staking token. In case of Bitcoin, it's a Bitcoin staking token. In Ethereum, there's a Ether. In our case, it's going to be RAV. What you need in these cases, and why it's important, I think that's exercise for you guys to why a staking token is very important for a blockchain. If you have any questions, probably you can, after this talk, you can see me, I can explain you. And you can get some of my my business cards by the table. And this is our approach. So some of the basic service we are going to create, and wallet, identity, messaging, timestamping, exchange, and this is our platform, what we call a verticals, and then some of the, these are the horizontal service and these are vertical service. I think I have not included some of the services other speakers already talked about. So let me wrap up with this one, and let me give you a little bit architecture also. It's a pretty high level architecture, how we are building it. Some of the database thing is a little different, and then rest of the things it's a stackable to make it a little bit understandable. That's all. If you have any questions, please feel free to ask, or I can explain some of the other things. Great, no questions.
Yeah, so I was just curious, with the 10,000 transactions per second, I mean, that's a pretty staggering number compared to the 20 on Ethereum. You look at the blockchain for Ethereum being about 260 gigs, which I saw on one of the slides earlier today. How would you combat that issue doing 10,000 transactions per second?
So let me take the space first, and then I will come back to the 10,000. So one of the space, if you have a 263 GB kind of blockchain size, the biggest risk with, I think, I don't know if you listed that or not, is the centralization. What happens if the normal person cannot have blockchain to themselves, right? Managing that hardware, managing the space is kind of expensive and cumbersome also. And then what happens if these kind of things happens, then your specialized hardware or specialized vendors come in, and the whole blockchain can get hijacked. So this is the one of the problems with the Bitcoin at this moment. I'm not sure if you follow Bitcoin, how mining is happening, how they create those blocks together. China has the largest number of mining rigs. They control, China as a territory, they control almost 60 to 70% of mining for Bitcoin, because electricity is cheap, and that's a problem with the proof of work. So from our side, now coming back to the question, so what we have, what we call the namespaces is our architecture is a multi-blockchain architecture, and that helps for the forking also. What Akshay mentioned in future, that how we can eliminate hard forking, right? So in our case, what will happen is you will create a namespace which is equivalent to a blockchain, and if you feel the space is going in a certain direction, it's increasing too much, then you can move to a different namespace. So start from scratch. I think that's the direction we are taking. So you can create multiple blockchain, and based on the namespace, and then you can change the namespaces. And for the transactions, the way we think we can achieve is that concurrency, right? So what we think is with using namespace plus concurrency, we believe we can achieve those 10,000. Of course, we ran some of the numbers with those numbers were in a couple of thousands, but definitely with the optimization of the code base and more how we get the what do you call concurrency, to improving the concurrency and namespace. I think essentially that's a key for us. Yeah.
Any more questions?
Thank you. Thanks for your